It defaulted back to taking you guys. Alright, so on lesson 2. So yesterday's lesson is this little timeline. You know what, I think it's hard for us to try and comprehend how old the Earth is. So I've got this and another thing. So if we take the current age of the Earth is 4.6 billion years, or 4,600 million years old. That's hard to comprehend. So if the Earth formed on the 1st of January, they were the oldest rocks. So the Earth formed, and then it was a ball of fire and gases, and then it cooled and rocks formed. Then the first bacteria only appeared near the end of March. Organic food runs out, so they were not photosynthesizing, they were feeding on other things, and then some bacteria became photosynthetic, and they made food and oxygen as a byproduct. Okay? Then the oxygen became the most common gas. Before that, it wasn't the most common, but because of photosynthesis, oxygen was produced. So you might remember from last year, where remember we talked about the age of the Earth, and that bacteria initially, they couldn't cope with oxygen, and a lot of those died out, but the ones that were able to evolve and develop aerobic respiration, which you did in grade 11, were able to use the oxygen from plants and also, eat food and break it down, using mitochondria, and they were able to survive in an aerobic atmosphere. So only in September, so that's the bacteria, those little unicellular organisms, prokaryotes. Only in September did the first eukaryotes evolve. So things with, what's a eukaryote again? A prokaryote has or hasn't? Prokaryote has or hasn't? Hasn't, and the eukaryote? Eukaryotes have got proper nuclei. So they only arose in September, alright? In near the end of October, a month later, then we started getting multicellular organisms like, hello Shreya. Then we started getting multicellular organisms like sponges. In November, first invertebrates, worms and jellyfish. Lots of radiation, lots of organisms evolving from common ancestors, becoming more complex and more diverse. So that phylogenetic tree that we're talking about. All right, and maybe fossils only started forming more when things were made of harder things like bone and that. But that's why we don't have a lot of fossil evidence, or the fossil record is very, it's not complete for long ago because the animals were soft-bodied or very small. Although they did find fossilized bacteria in Australia inland. So the minute you see something like that, and those bacteria were aquatic, it must have been an inland sea. So this is just going back to grade 10 and remembering that a little bit. Alright? Using fossil evidence to figure out what was there. Was it a sea? Was it a land? What type of animals and plants lived? How long did they live? How long were those, the range. I have to show in another picture, we have done it before, but if the fossils were only present from 300 million years ago to 200 million years ago, and then they died out, so you can get an idea of how long those organisms were around for, depending on what fossils you find. Does that make sense? Okay. So then the first invertebrates, so worms and jellyfish, then lots of invertebrates, so that would be the insects. And insects are actually the most common organisms, and bacteria, alright, and probably viruses too, because we don't know all of them, and also flowering plants are very common, okay? So then you get all the vertebrates, the first fish, the first coral reefs, and corals are little unicellular organisms that live in a calcium carbonate skeleton that they make. You know when you buy a natural sponge, it's got little holes in it. That's where the little unicellular organisms were living, and they would filter feed with their, not flagella, what are they called? Little cilia. They would filter feed from the water. But it's multicellular, not multicellular, little colonies of little unicellular organisms living in a calcium carbonate, like, I don't know, shell. Alright? Then first reptiles, then mammals. Mammals emerged before first birds. In fact, in the Karoo, they have found fossils of the first mammals, and they're called therapsids. And in one of my PowerPoints, it actually shows you them. They looked, they walked on all fours, but they looked kind of like dinosaurish, but they had fur, and they were very big, and so they've actually found fossils inland, in the Karoo. of those. Alright, so I'll just try and go there when I show something. And then only, look at the dates now. 19th of December, first flowering plant. 25th of December, last of the dinosaurs, they went extinct. Primates, our group, only appeared the 26th of December, and then you've got all the early hominids, Australopithecines, all the early Homo genus, Homo species. What are the others? There's so many, okay? Ardipithecus, things that you don't know yet. And you won't have to know all of them anyway. And when did the first bipedal hominids, so early humans, arrive? First upright bipedal, remember that from, did we do that in grade 10? No, I don't think so. So bipedal, so they used to, not us, but ancestors that died out used to walk on all fours, and then when they started running through grass, or they not started running, if they were able to walk upright, then they could move quicker through grasslands and see further. So they had a gene, a mutated gene that allowed them to be more upright and not arboreal. You know what that means? Living in the trees, making sleeping places in trees. That's what they postulate from the evidence, from the fossil record. All right, then you get Homo erectus, so the first Homo species, then an ice age. Look at the time here, 2 o'clock in the afternoon, 9 o'clock at night, quarter to 11. 11, now primitive humans could cook food. Fire, being able to use hard food sources, cook them down, make them easier to digest. Maybe that's, maybe the reason our teeth are now so flat, and that is because there was a mutation, and it didn't matter if your teeth became flat and not all pointy like a dog. But I'm not saying we were that. Okay, if you go back in the record, you can see the progression in the teeth. Mutations, chance mutations, caused the teeth to be different, but that didn't matter. That's what the fossil record is showing us. Okay, we are able to still eat different types of food, and we can cook our food. Neanderthals appeared at 12 minutes to midnight. Real Homo sapiens. So we're talking about early hominids or hominids. Us, we appeared at 6 minutes to midnight. Australian Aborigines, because they say that Homo sapiens, or they postulate that Homo sapiens emerged in Africa and then moved out into Asia, down those islands, and to Australia. There's a lovely little animation video that I show. Alright, so that only happened here, so there were settlements elsewhere in the world. Agriculture, growing your own food. Before that, hunters and gatherers. Okay, look at that. At 11 seconds before midnight, the beginning of recorded history, when people started writing things down, historians and naturalists, is at 32 seconds before midnight. I think I got the other time wrong. It was 1 minute 11. And then watch here. Beginning, okay, so then pyramids built at 31 seconds to midnight, Buddha, Christ, whatever, okay, all the other religions emerged, all right, and then I'm not sure of Battle of Hastings, is that important? Okay, maybe, I'm sure Mrs. Jones, okay, all right, and start of scientific method, proper studying and all of that. Doesn't that astound you? We've been around since then. And look at what, look out there, look at the progression, but also look at things like climate change and that. Makes you think. Now there's another little thing.
Our lifespan is median and
Exactly. We've been around the shortest and so much change. So now this little thing, if I can get it off with my really cold hands. Okay, so what you're supposed to do, would you hold one of these? Okay, so would you hold whoever? We're going to look at it. Go stand that side. So this is the, would you hold the iPad to follow us? Okay. Alright, so, Amy, I have to do my half an hour to unlock it. I'll do that. It's not like this. You just can take it out. Charge plates if I need to. Is it still recording? Yes, it is. Okay, just hang on. You can hold it up and just. So if you hold the beginning, okay. So okay, right at the beginning here is the formation of the earth, and for a long time there was nothing. Then the first bacteria emerged. Alright, first signs of life. Then all the way down here, there is oxygen built up. So now there were bacteria that were photosynthesizing. So now it became an aerobic atmosphere. Alright, and other unicellular organisms emerged. Then over here, the first simple multicellular organisms. Then here, the first fish. So somewhere in between here was the invertebrates. Alright? And then first land plants, very simple land plants. Here's first insects. It's a little bit different to that one. First insects, reptiles, okay? Early mammals, so dinosaurs, somewhere here. Early birds, so mammals. You see now they put this the other way around, you see that? Because there it said, it was right, hey, mammals first? No, birds. We have to go look. We can read off a table. And then right at the end here, human beings. Alright, so that just gives you an idea of how everything, lots of things happened recently, and the age of the earth is very old. Okay, just leave it laying like that and I'll roll it like that. You can sanitize your hands.
On the back table.
You can sanitize your hands. And I'll roll it up there. Now the analogy, okay? You can close the door. It's a little bit cold. Alright, so then you can go watch that other video on Google Classroom, and any little video